Hey everyone, so in this video I'm going to go through an example of how to solve a rational equation. So that's what we have here. We've got a rational equation, and we can tell that it's a rational equation because we have at least one rational expression that appears in it. So step one is going to be to move everything to the same side of the equal sign. So that positive 1 on the right side, we're going to move over to the left side by subtracting from both sides. So that's going to give us 2x over x minus 1 plus x minus 5 over x squared minus 1 minus 1, and we're left with 0 on the right side. Okay, so step 2 is going to be to take these expressions and basically put them together into one big rational expression. And to do that, we know that we're going to need a common denominator. And it's easiest to find a common denominator once everything's factored, at least all the denominators are factored. So why don't we start by factoring? So we can't factor the first rational expression. The second one, we can factor the denominator into x plus 1 times x minus 1. Okay, so that's fully factored. And now that it's fully factored, we're going to check to see which factors appear in the denominator of each of our rational expressions and see what's missing. So for example, if you look at the middle rational expression, we've got a denominator of x plus 1 and x minus 1. You're going to notice that x minus 1 appears as a factor in our first rational expression, right? There, 2x over x minus 1, but it's missing x plus 1. So the first thing I'm going to do is I'm going to put a factor of x plus 1 in that first rational expression by multiplying on the top and the bottom by x plus 1. So we have times x plus 1 times x plus 1. All right. And then also that minus 1, we have to deal with that, and that also has to have a common denominator of x plus 1 times x minus 1. So I need to rewrite 1 with a denominator of x plus 1 times x minus 1. Well, the good news is x plus 1 times x minus 1 over itself should be 1, so I'm going to replace that with x plus 1 times x minus 1 over itself. And now everything's got a common denominator. So we're next going to expand out the tops so that we'll be able to simplify a little bit easier. So 2x times x plus 1, so that's going to give us 2x squared plus 2x over our common denominator. Our middle rational expression there isn't going to change, so plus x minus 5 over x plus 1 times x minus 1. And then when we expand it, the top of our third rational expression, x plus 1 times x minus 1 is x squared minus 1 over x plus 1 times x minus 1, and of course we have all that equal to 0. Okay, so now that the numerators are all expanded out, we can combine these three rational expressions by adding and subtracting the tops, right, the numerators. So 2x squared, let's see, I don't have an x squared term in my middle numerator. At the end numerator, we do have an x squared term, so we're going to have 2x squared minus x squared, which just gives us x squared. All right, we have an x term in our first numerator, so 2x plus x from our second numerator, and there isn't one in the third the third numerator, so 2x plus x is plus 3x. Okay, we don't have a constant term in our first numerator. Our second numerator we have negative 5, and then our third numerator we have minus negative 1. So negative 5 minus negative 1 is negative 4. Okay, that is over our common denominator of x plus 1 times x minus 1, and all of that is equal to 0. So now we've completed step 2. We've got this into one big rational expression, and that rational expression is equal to 0. So here's the thing. The only way you can have a rational expression which is equal to 0 is if the numerator is equal to 0. That way we'll have 0 over some number, right? And we know that that gives us 0. So we're going to move on to step 3. We're going to take the numerator and we're going to say, okay, it has to be equal to 0 for the whole expression to be equal to 0. So we create a new equation from this, x squared plus 3x minus 4 equals to 0. And notice that by doing that, we've taken this rational expression, or this rational equation, and we've turned it into a polynomial equation that we now have to solve. So we're now going to solve x squared plus 3x minus 4. So let's do that over here, and we're going to do it by factoring. So it factors into x plus 4 times x minus 3 equals 0. Okay, the solutions to this are x equals negative 4 and x equals 3. Okay, so these would be the solutions to our rational equation, except we have to remember one other thing, right? Step 5, we need to check the restrictions on our original rational equation and just double check to see that none of the restrictions are the solutions to the equation we got, because if there's a restriction, we know that the function is not defined at that value. So in other words, that can't be used as an x value in our equation. So if our solution happens to be one of those x values, well, we have to pretty much just just disclude it. It's not an x value that's allowed in the equation. So the restrictions in this case, so easiest to do this is to go to the factored form that we have everything, and it looks like our restrictions are x is not equal to positive or negative 1. Notice that neither of the solutions we got is positive or negative 1 from our equation, which means that x equals negative 4 and x equals 3 are our solutions. So this has been how to solve a rational equation. Take care.